Let's continue from the subtopic, which is hydrolysis of salts. But once you hear the word hydro means water. And when you introduce water to salt, you call what? Hydrolysis of salts. Now, this is the reverse of neutralization reaction. Okay, so when a salt is dissolved in water, a solution which is either acidic or basic is formed. So the reaction of a salt with water to form acidic or basic solution is known as what? Hydrolysis. It is the reverse of what? Neutralization reaction. For example, let's look at this. Let's see how a normal salt is formed. For example, if we add a normal salt with water, okay, we're going to have a strong acid and a strong base. So we neutralize what? We neutralize a salt. This is a neutral salt, sodium chloride, being introduced to water. So what type of acid will be formed? Strong acid and strong base. In other words, if we react a strong acid and a strong base, okay, you're going to get what? A neutral what? Salt that is formed. Because there is a complete neutralization of what? Of the H plus, okay, with the OH minus present in the sodium hydroxide. All right. But when you add what? Water to acidic salts, okay, you're going to have what? A strong acid and also what? A weak base. Because at this case now, there is no complete what? Neutralization. And so on and so forth. So basic salts, okay, you give us what? Weak acid and a strong base. Neutral salt, of course, you give us what? Weak base and also what? A weak acid. This is an organic salt. That's why you're going to have weak base and weak acid. Don't forget, this is organic salt. So you can give us what? Organic acid and what? And a weaker what? Base. So the process in which what? Water is added to a salt is known as what? Hydrolysis of salt. All right, so let's proceed. All right, preparation of salt. This is the process in which salt is produced. All right, general concept. First of all, you depend on the kind of salt you want to produce, right? So this is your acid, for example, sulfuric acid, and this is your zinc powder. You introduce it to what? You dissolve your zinc powder in what? In the sulfuric acid. Dissolve your what? Your zinc into sulfuric acid, alright? You stir, okay? What happened? The zinc powder will not dissolve completely. So something is going to happen, okay? You're going to give us an insoluble solution. So when you now filter it up, you have what? You have what? This is a glass rod that help the filtration. Then zinc sulfate settle at the base. Is that okay? Alright? Then what happened? You now transfer this to what? And heat. So all the water here will now do what? Evaporates. Okay? And a crystal is formed. When you dry, you get your dry crystal. So the general method of preparing what? Preparing salt by, okay, neutralization what? Process. Okay, let's look at other ways in which salts are produced in a laboratory. So, salts are produced based on two parameters. For the first one is how soluble is that salt in water? And how stable is that salt in water? Okay? So we produce salt based on their solubility in water and also what? Their stability to heat. Okay, so what are the methods of preparing soluble salts? We have basically four methods. All right, the first one is what? Neutralization reaction of acid by an alkali, action of dilute acid on the metal, action of dilute acid on the insoluble base, action of dilute acid on what? On trioxocarbonate, what? 4. All right, then we also have basically two methods to produce what? An insoluble salt. That is salt that will not dissolve in water. Don't forget, the first method is called double decomposition or precipitation process. For example, this compound now, lead 2 chloride is a precipitate. All right, it's solid. It will not dissolve. No matter the amounts of water you add to this salt, this particular lead 2 chloride, it will not dissolve. Okay, and also by combination of the two elements. For example, for you to get iron 2 sulfite, what do you combine? You combine iron and what? And sulfur, and you got this. So this salt and this salt are insoluble in water. We call it what? Direct combination of the elements and also double decomposition of the elements. So insoluble method of preparation of salt and what? Preparation of soluble salt. Okay. Okay, take it as assignments. So you're going to define what is efflorescence. Don't forget, I said all these are processes. Efflorescence, deliquescence, hygroscopy. Okay, your assignment is go and look for what are drying agents and list all the gases and their respective drying agents. Don't forget, drying agents are always deliquescence or hygroscopy. Why? Because hygroscopy will absorb moisture and form solution, whereas hygroscopy will absorb moisture but will not form solution. So look that in your textbook and add to your knowledge. Okay, the next thing is the pH scale. All right, this is the measure of the degree of acidity or alkalinity of a solution. This shows us whether a compound is basic or what, or an alkaline. Now, this is a pH scale, number from 0 to 14. So any compound that falls between 0 and 6.9, that compound is always what? Is always acidic in nature. Okay? But any compound that has pH exactly of what? Of 7, that compound is what? Is neutral. Example, your pure water is neutral. You want a pH of 7, it has no effects. Okay? Then whenever a compound has a pH of 7.1 down to 14, that compound is what? Is basic. And this thing works like this. Alright? You can see the arrow is from here comes down. This shows what? This shows increasing alkalinity. Alright? From 8 to what? 14 means that if a compound has a pH of 14, this compound is more basic than a compound that has a pH of what? Of 7.1 or 8. This is increasing basicity. Okay? This is what? Increasing what? Acidity. That means that if a compound has a pH of 1 or 0, that compound is very, very acidic. Okay? But if you have a pH of 6, it's less acidic compared to what? The pH of 1. So this is the increasing ability from 0 to 7 and from 7 what? To this. So these are some examples of compounds that are basic, okay, neutral, and also what? Acid. Okay. So the degree of acidity and alkalinity of a solution is known as what? The pH scale. And the pH on its own is defined as what? The negative logarithms of the hydrogen ion. Okay? Concentration to base 10. While pOH means what? The negative logarithm of what? Of hydroxide ion to what? Concentration of base 10. Alright, so this is not in today's, just to give introduction. We are not solving any maths today, but in case it comes in exams, to find the pH and pOH, this is the formula you're going to use. We have 4 formulas here. If you ask to find the pH of a compound, equals to minus log hydrogen concentration. Alright? Then if you have to find pOH, the same thing, minus log the concentration of hydroxide ion, which is this. This is gotten from here, alright? This is gotten from here. But if you are giving pH and pOH at the same time, what do? This is a relationship. You use pH plus pOH equals to 14. 14 is what is the total scale of your pH scale from 0 to 14. Okay? So it depends on how they choose the question. I can also use what? This equals to this. Okay? So we have 4 in one formula here. The first one is this. Alright? Second one is this. The third one is this. And this is the fourth relationship. Depending if the question comes, don't forget this formula. And also it's shown in the other diagram. Alright. Okay, we have done it before. So pH less than 7 turns litmus paper red, shows that it's an acid, salt, test, and so on. So this further explain the characteristics of base or what an acid based on their pH level. All right. So strong acid, strong base give us a salt and water. Example and Cl. So NaCl here falls under the pH of what? Of 7 because it's a neutral salt. If a compound contains H, it falls between the 0 and 6.9. If it contains OH, it falls between a pH of 7.1 down to 14. All right, so let's proceed. Okay, the same as illustration of what I said before. Okay, so let's look at some question. Some jam question regarding salt, acid, base, and salt. The question is, the equation H plus plus OH minus equals to water illustrates all right. So this is neutralization reaction. Why? This simplifies your acid. Okay? This simplifies your acid. This simplifies what? Your base. When they come together, a water is formed. So the answer there what? Is D. Complete neutralization reaction. Question 2 says, which of the following is a deliquescent compound? All right, of course, you know the answer now. A substance that absorbs water and dissolves to form what? A solution is known as what? Deliquescent. And the process is called what? Deliquescence. So which of them do you think is the answer? I know you know, but let us look at the answer together and the reason. All right, the correct answer there is what? Is B. Why? Calcium chloride is what? Is deliquescence. All right, but this is what? Efflorescence. CuO is what? Is hygroscopic. Okay, this is hygroscopic. It will dissolve, all right, but it will not form solution. And this is a normal salt that will dissolve. Okay, so the answer there is what? Is B. Number 3 says, which of the following acid forms normal salt? Only normal salt. The question is that which of them now? Okay, let's look at the explanation. All right. This is a strong acid, and this is a weak acid. So when this compound dissociates in water, it's going to give us what? Just one hydrogen basicity. For example, we have CH3COOH. That will give us what? CH3, okay, COO minus plus H plus. So this is only what? Only one atom of hydrogen involved. So normally, it's easier for this acid to neutralize by the base and give us what? A normal salt. Because this is a strong acid, and a strong acid. All right, let's continue. A substance is said to be hygroscopic if it absorbs. Okay, we know what it means now. The answer there is what? Is D. Moisture from the atmosphere without dissolving. So it's the opposite of what? Of deliquescence. Next question is, which of the following compound reacts with sodium hydroxide to form a salt? Of course, the answer is A. Why is it A? Because this is an acid. All right? This is an acid. This is alkanoic acid. All right? So, with the presence of COH, this compound will do what? We quickly react with the base and give us what? A salt. All right, question number 6 says, which of the following is the general method of preparing acid? General method, okay? Whether it is insoluble salt or soluble salt, general method is what? The answer is what? Is A. Direct combination of what? Of constituent elements. And other ways, other methods, other explanations involve dissolution of acids and hydride by combining constituent elements and so on and so forth. So whether a compound is a soluble salt or insoluble salt, the general method of preparing a salt is by what? Combining the respective elements together. Okay, let's go for a brief break. We'll be back soon.